Welcome back, guys, to our DSA challenge series. This is the phase 5 of our series, and the questions that we are tackling in this series are based on Q data structures. So let us see our today's question. The today's question says reveal cards in increasing order. So let us understand this particular question. We are given an integer array deck. Deck denotes that there is a deck of cards where every card has a unique integer. The integer on the ith card is deck at the index of I. Now we can order the deck in any order as we want. Initially, all the cards start face down in one deck. Now what we can do? We need to do these following steps. We need to take the top card of the deck and we need to reveal it and take it out of the deck. If there are still more cards present in the deck, then we need to put that next top card at the end, at the bottom of that particular deck. And we need to continue this particular procedure till our deck is empty. Now the twist is we need to return the ordering of the deck such that the cards that would be revealed, the cards should be revealed in an increasing manner. So now let me summarize the question. We were given a deck which consists of cards 17, 13, 11, 2, 3, 5, 7. Now we need to return an ordering of that particular deck such that the cards that we are going to reveal, they should be revealed in an increasing order. So what is the procedure? The very first card we will reveal and take it out of the deck. The next card we are going to put at the bottom of the deck. Then in this particular deck, 17, 13, 11, 2, 3, 5, 7, what we need to do is we will reveal the first card 17. Next 13, we will put at the end of the deck. Then we will reveal 11. 2, we will put at the bottom of the deck. 3, we will reveal. 5, we will put at the bottom of the deck. So in this way, we need to do this procedure till our deck is empty. Now the question says we need to return an ordering in a way such that the cards should be revealed in an increasing fashion. Increasing fashion means in an ascending order. So how can we achieve that particular ordering? That ordering can be 2, 13, 3, 11, 5, 17, 7. Now what will happen? When we will reveal 2, we will put 13 at the bottom of the deck. So our new deck will become 2 is revealed and it's taken out of the deck, and 13 is put at the bottom of the deck. So new ordering becomes 3, 11, 5, 17, 7, and 30. Then what we will do? We will reveal 3 and we will put 11 at the bottom of the deck. In the similar fashion, we will keep on doing till our deck is empty. So how can we achieve this particular order? So let us see that particular thing. Initially, we were given a deck of cards. So what we will do, first of all, we are going to sort that entire array. Suppose if we were given a deck of cards numbered from 1 to 50. So what we will do, we will first of all sort that entire array. So the sorted array will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. As you can see in this particular image. Now to achieve that particular ordering, we will take the help of a Q data structure. We will take one, insert it. After that, we will leave one position. Then we will insert 2. Then we will leave one position, we will insert 3. Then we will leave one position, we will insert 4. And we will keep on inserting. Then at the last position 8, we have inserted a number. So at the next position, next empty position, we will leave. We are now the empty positions were this one, this, and this. So since we have inserted at the last position, so we will not insert at this particular position. We will leave one position, then we will insert the 9. Then we will leave one position, then we will insert 10. Then we will leave one position, then we will insert 11. Then we will leave one position. Now, since we have left the last position, now we will keep on inserting from the first empty position only. So this was the empty position. So we will now insert 12. Then we will leave one. Then we will insert 30. Now again we will leave one. So in this way, we will keep on inserting the elements. So the ordering that we will get now is 1, 12, 2, 9, 3, 14, 4, 10, 5, 13, 6, 11, 7, 15, and 8. Now, in this particular ordering, when we will reveal 1, we will put 12 at the end. Then we will reveal 2, then we will put 9 at the end. So the cards will be revealed in an increasing fashion. So I hope the approach is clear to you all. First of all, we have sorted that particular array. After sorting to that array, we have inserted the elements by leaving the 1, 1 positions. because the question says we need to reveal the first one and the second one we need to put at the bottom of our deck. So we have inserted it in that particular manner such that one we have inserted, then we will leave one position. Then two will be we have inserted, and then we will leave one position. Because at the time of revealing the cards, we will reveal one, and whatever number is over here, we will put it at the bottom of the deck. Then we will reveal two. Then the next one will be put at the bottom of the deck. So in this particular way, the cards will be revealed in an increasing fashion. Now, how can we achieve this particular configuration? So let us understand this with the help of a code. See, what we did is we were given a vector of deck. In the line number 4, we have sorted that entire vector. After sorting, we have taken a variable n in which we have stored the size of that particular vector, that is deck.size. In the line number 6, we have made a data structure q int q, and we have taken a variable int I is equals to 0. Now, in that particular queue, we are putting the indexes of that number. Indexes like 0, 1, 2, 3, 4, 5, 6. So in the queue data structure, we have inserted all the indexes. After inserting the indexes, what we did is we have made a variable ans n, in which we are going to store that particular order. For int I is equals to 0, I less than n, I plus plus. Then what we did is, now this is the main step. Ans at the index of q dot front. Q dot front will denote index number 0. So ans at the index of 0 is equals to deck at the index of 0. Understand it with the help of an image. Ans at the index of 0 denotes this position. Deck at the index of 0 denotes this. So ans at the index of 0 पर क्या आ जाएगा? Deck at the index of 0, that was 1. So ans at the index of 0 will get 1. After what we did is we have popped q dot pop. Now 0 will be left from the queue. Now 0 is not present inside the queue. After that, what we did is q dot push q dot front. Now q dot front denotes index number 1. That index number 1 now comes at the end. After that, we have popped it up. Now, in the next iteration, ans I value will become 1 and q dot front will become 2. Now q dot front will become 2. So ans at the index of 2 will equals to deck at the index of 1. Ans at the index of 2 will denote this position. Deck at the index of 1 will denote this position. So we will be able to achieve this particular configuration. We are inserting, then we are next index we are pushing at the end of the queue. Then we are inserting, then the next index we are pushing at the end of the queue. So in this way, we are able to achieve this particular configuration. And once this for loops end, we will be able to achieve the order such that it will reveal the cards in an increasing fashion. So I hope the question is clear to you all. Just go through the code once. It will be much more clear to you all. So if it is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.